Hey, welcome to the first episode of an exciting new series I'm starting on a universal damage system. This is kind of a branching point from our main series. Other series that I've been doing is the interaction and inventory system. We've got equipment on our character, and now we presumably need a way to do damage. And specifically for that series, we need a way to, before we get to crafting, ideally we would need a way to interact with trees and rocks and stuff to mine them or chop them down, and then get the resources and then be able to craft them at a workbench or something like that. Just kind of modeling. That system is modeled off of Valheim, and that's what they do in Valheim. However, a damage system can get, as simple as it seems, it can get really complicated depending on the scope of your project, because there are many different ways that you will need to do damage. For instance, you chop down a tree. If you want the tree to fall and roll and maybe hit the player and do damage, that's like a whole different way to do damage, right? Because it's not like the tree has a sword and it's the sword mesh that you need information about to do the damage trace that you're going to trace for damage. You would just need to know about the trees, whatever collision box. And for instance, if you do have a player will have an equipment like blueprint, and will need information on that equipment's collision box for damage. However, in a lot of cases, you may have like an animal or an enemy AI that needs to it only has a mesh attached as a weapon. It doesn't even need a blueprint, and so you would then need access to that mesh's collision box, but it's actually just on the actor that owns it, instead of it being a whole nother blueprint. So you can see how there's a lot of different. And another thing is, in some cases, when you're building out your damage and you're kind of passing it into the other systems, you may be calling the damage event on an equipment, but you want to pass in something totally different. Like a player may have damage stats associated to it, right? But if its sword is attacking, it's not the sword damage that you necessarily need. It's the player's damage too, or it could be each. It could be either or a combination of both. And so you really need not a diverse, but a really modular and scalable system that we can set up that will allow that functionality, but also damage resistances, like easily be able to set damage resistances on what level things are resistance to different damage types. And we'll need damage types like slash, impact, blunt damage. We'll need elements like elemental damage, fire, ice, electricity, maybe even status, not maybe even, but definitely status effects. So if you shoot someone or hit someone with fire damage, at some point they'll catch on fire. And there's just many different things to take into account if you're building any kind of damage system for most games, I would say, outside of just something very simple. And in a lot of ways on YouTube, I haven't really seen a tutorial that does it in a very modular and scalable way, and anything I have read or seen kind of pigeonholes you into doing it a certain kind of way. And I aim to basically have a damage system that exists, that can be accessed from anywhere in the game. Any actor can call that, hey, I need to look for a damageable actor, and then we can delineate between all kind of different damageable actors. Like some, when you damage an actor, some may need to fall down, some may need to do a hit reaction, some may need to explode, and so we'll have that functionality. So our system needs to do a lot of different things, and that is what I aim to do. And I've kind of rambled enough. I've started to make presentations. I don't know why that's right. Okay, there we go. I've started to kind of put together little, overviews, presentations, and I'm actually going to start including the link to these in the description. And I just want to remind everyone, if you have any trouble, get in the Discord. We have a lot of engagement, a lot of people there to help. I'm in there every day. I can help answer any questions. And if you're interested in the project files, just to use the system or to learn from it, check out the Patreon. So let me get into this. Also, the link for this presentation will be in the description. Feel free to check it out. And so I've kind of made a little thing. I made a little overview of just my thoughts. It's nothing super sophisticated, but I figured, something like this may come in handy just to keep us on track and set goals for the series in general, but also as a reference for people, So hopefully you guys get some use out of that. And one more thing before I start, I just wanted to show you guys in Notion. A lot of people have been talking about, have been asking me the plans for different series and stuff like that. And I'm putting together a public roadmap basically for the channel and all the series. And you can kind of see I have like a channel roadmap, and these are all the different things I'm planning to do. And it has like a status on it basically. And then I have just a release schedule of when we are planning to do different videos. And then we have each individual series that is currently active, or I should say each individual project that is currently active. I'll create a roadmap for it. Now I'm just in the process of implementing functionality. You see right here, I have it typed just to remind me, but each one of these, I'm going to accept the release schedule. I'm going to put a button to where if you want to suggest features, one will automatically be added to the considering section of, or in the project one will be added to this ideas one. But so you guys can suggest things, and then I can try to implement whatever features you guys wish to have. This is probably a week away from being complete, and then you'll be able to find the link in the Discord. Cool. So where was I? Oh yeah, sorry. So here we go. So I have just a brief description of what the system needs. So the system should be able to define custom shapes to use for traces and check for entities that it can take damage. Right, so we're basically going to have a collision. Instead of using sockets or anything on skeletal meshes or static meshes, we need to be able to put a collision volume on anything. It doesn't have to be a mesh, doesn't have to be anything, it doesn't have to be anything. That's why we're going to use meshes, because we don't want to depend. That's why we're going to use collision volumes, because we don't want to depend on any other component, right, to get the shape or to get the scope of what shape we want to trace. So we're just going to use collision volumes, and we will deduct the shape from that and then run our traces. So the system also needs to take in many different actors and compile final damage values. So you need to be able to pass into the system as you're doing it, as you're tracing for damage. You need to be able to tell that system right then and there or later where the damage is coming from. So it's a dynamic thing. It's not like the system will look at a data table or whatever damage you are tracing for, you will then pass in the data for that damage, and that damage data will define what to do with once you've made contact. Our different damage types, and so we're gonna have different damage types. So I'm gonna do blunt. So I'm gonna do physical damage, which is just like environmental damage, or I should say I'm gonna do pure damage, which is going to be environmental damage. So that's one type of damage is pure. All right. There's another type of damage which we'll call physical damage, and that will have different subtypes, which will be blunt, pierce, and slash. And then we will have we'll have chop and mine too. So for tools, for instance, and then we'll have 4 elements. We'll have 5. We'll have kinetic, which is just regular, no element, and we'll have explosive. We'll have fire, shock, ice, and poison or something. And we'll have 5 different categories of damage resistances. We'll have immune, very weak. We'll have immune, very weak, neutral, resistant, and very resistant. Okay, and so we'll have to work out, we'll have to do a kind of complex damage calculation. First of all, we'll have to source the damage from maybe a couple different things, right? We may need the player's base damage value with the equipment base damage value, combine them somehow, and then do our damage calculations on the damage resistances and damage types. And so elemental damage intake and pass along necessary data. Yeah, that's what. Oh yeah. So when we need to consider elemental damage when necessary, and then have a call to our status effect component to, roll a status effect on this, and if it passes, apply a status effect, basically. And this is important too. We need to delineate actors that can actually take damage versus actors that can be hit. Like an actor may be able to be hit, the ground, for instance. If you shoot the ground, you may want it to be hit technically and produce sound effects or visual effects, but you don't want it to necessarily take damage, if that makes sense. So our system needs to be able to separate those two. And I kind of already went over this, but the system needs to be accessible from anywhere, in many different ways. And basically, any actor from anywhere can access, or any object from anywhere can make a call to the system and say, hey, trace this shape, and it'll work. Yeah, it needs to be standalone and universal, so instant damage over time, even AoEs, for instance, like area of effect stuff, explosions. And I've already said executing very different responses upon taking damage. So, for instance, we don't want to always produce a hit reaction for every damageable actor. We may want something else to happen. There may be an explosive barrel that doesn't do a hit reaction at all. Maybe it's just an enemy that does a hit reaction. So we're not going to tie that to our damage system concretely. We'll be able to choose on each individual actor what we need to do upon taking damage. And I didn't even put in the system needs this, but there is a UI element to this. For instance, we'll probably want damage numbers. We will want different damage numbers. We will want an animation when you do damage, right? Like pops up and then goes away. We will also want to indicate, because we're going to do critical hit chance, and because it's just, I'm going to do it with melee weapons basically. And so we're just going to, when you go to do damage, it's going to say, hey, roll, do a % chance for a critical hit. And if it does do a critical hit, we're going to want to maybe make the damage numbers red instead of white, right? But if it's an element, we'll also want to change the color of the damage numbers to match that element. So I didn't put that in here, but we will be covering that as well, like some UI elements to it. And just, I didn't mention this either, but this has nothing to do with health. We actually already have what would serve as a health system in our ability system. My gas-inspired blueprint ability system tutorial series is 3 episodes as of now, and on the 3rd episode we go into a pretty robust attribute system, and we're going to use something like that to actually have a health value that we subtract from. But that is really not what this series is about. It's more about like the reactionary and just like, this, not the actual simulation, but just defining what happens when damage is involved at all, and doing complex calculations instead of just subtract from health, if that makes sense. And so I kind of wrote this out like our infrastructure. We're gonna create our custom game state, which will be accessible from anywhere. Like you can type, get game state and get the current game state from anywhere in the project, but you would have to cast to your class of game state, but we're gonna throw a component on it. So we'll be able to just get component by class and get our collision trace component, and then pass the information to that on whatever we want to trace. And so on our damageable actors, and these are our actual damageable actors, like the ones that actually need to take damage and do some kind of reaction or whatever, they'll have a damageable component, and we'll check for that before we apply damage. For impact actors, like the ground, if you hit the ground on accident or something, you may want sound effects or visual effects to fire. We're going to separate that from just, maybe you have a wall that you want to do that, but then you have a wall that you don't want to do that at all. We're gonna define a custom trace channel, and that's how we'll define for if we want to produce sound effects or impact effects, and we'll only take damage away if they have the damageable component. And then on the damaging actor, which I'm going to call the damaging actor, is going to be, we're going to have damage causer, which will be the actor that has the collision on it, and included with it. But then we're going to have like instigator, and that's going to be, for instance, if that actor has an owner or something. And then the data we're going to need is kind of expansive, but we'll need damage types. So I've already went over the damage types and elements, and we'll just need an amount and a critical hit chance, critical hit bonus, basically. And now when we're passing in our damage, it will actually be an array of this data, because you may want like for instance, if you're trying to chop down a tree with, a knife, you don't want it to just do no damage most of the time. You want it to do, if it's doing 25 damage, you want it to do, like 20 slash damage, but 5 chop damage. So when you try to chop down a tree with a knife, it's not just not working. It's like doing it, like you can technically do it, but it's just going to take forever. And so we'll have to make an array of this damage data right here, and be able to mix and match different things. You may want something that has, 10 fire damage and 10 electricity damage and stuff like that. So we're going to have to separate. We're going to have to do some structural trickery to get that to work, but we'll go over it. And we're going to have another main part of our data is going to be damage resistances. So damage type and resistance, I already went over that. You'll have, all the damage types and your resistance level to it, which will be resistance, immune, and it won't be numbers yet. We're just going to define it as a category, basically, of what's your rating, and it's going to be resistant, immune, weak. Okay, and then we're going to need some auxiliary systems for objects and stuff. Like in a perfect world, we would have a damage calculation object that when we go to apply damage, like there may be certain scenarios in where you don't want to do all these complex calculations for damage. Like if the player's taking damage, for instance, you don't want to necessarily get this and this and this and this. You just want to do a simple damage calculation on the damage that was passed in. And that's why we'll need damage calculation objects to define what calculation you want to make when you're doing this damage. Because if the player is damaging something, then you're going to want to get the player's base damage stats and the weapon's base damage stats, and maybe he has temporary boosts from consumables that have damage increases and damage stats. You're going to want to combine all that. So we'll build the calculation into an object and be able to switch those out on command, if that makes sense. And eventually we're going to go over the elemental particle effects and how to trigger them, projectiles, equipment, and try to show how to use this system in every single way you could think of, basically. And we will actually, this is something that is relatively new that I've been doing, because you have to understand, to arrive at something like this and kind of knowing all the possible holes and different little edge cases and things you need to implement logic for. It doesn't happen in a vacuum. I've tried to do this system in my own projects, 10, 20 times. And one of my latest findings is that in a lot of scenarios, you will want to damage things that aren't blueprints. If you use the foliage tool, if you use PCG to generate meshes, it doesn't really make sense for those things to be blueprints, because that's the whole point of them, is to not use blueprints and to take advantage of instant static meshes, which basically you can put 1 million meshes on the screen for the cost of one. So you can imagine the blueprint performance. If you have even, 300 blueprints, that's a pretty big performance hit, compared to one mesh, but there is a way to do it in a way where we can basically have the exact same functionality. We can use the foliage tool and the PCG tool and all these tools that take advantage of hierarchical instant static meshes without the downsides by using these components. Foliage instance and the PCG component, for instance, we can make our own children classes of these. And basically, they will serve as our damageable component, but for foliage and PCG meshes, if that makes any sense. And then we can basically get the exact same functionality and not have to have blueprints everywhere that, take up a lot more processing, which I don't see many people go into at all. But if you're actually trying to make a game, odds are you will need to use those at some point. You will need to paint down grass or rocks or something that you need to interact with in some way, and that you just can't simply make blueprints, or transform it to a blueprint when you get close or something like that. It's just not logical. So we'll definitely go into that as well, and that's a part that I'm really excited about. And then we have status effect game. Okay, so how we're going to do this is we're going to have a data table for our base. When I say base stats, I mean this is like for the game, for your project. These are the base stats for status effect stats and damage resistance stats. So for our status effect base game-wide stats, we're going to have a status effect chance, status effect rate, and a status effect damage. And this will be the base values for your whole game. At any point, if someone's trying to apply status effect, they can take their status effect chance and rate and damage and stuff, but they're going to have to combine it with the base values. So we can define that, hey, when an element hits an actor, it has a base 10% chance of applying a status effect, and when it does apply a status effect base damage is 5 damage once per second for 5 seconds, and that's going to be everyone. If someone applies the status effect, they have to check that data table first. And that just makes it so you don't have to keep, you're going to have to, if you change these values midway, or you're going to end up changing them a lot for testing purposes, and we would rather just have them in a data table. And it's the same thing for damage resistances. You're going to have to change these values a lot. And think about it. You don't want it to be inconsistent. You don't want a tree that is resistant to blunt damage to take less of a, to its resistance to be higher or just random. You would rather have categories. So we're going to put our damage resistance table is just going to say, if you're weak to damage, what percentage of that damage do you take? And if you're resistance to damage, what multiplier do you use? And those would just be the game-wide based values that we always use. So we don't have to ever hand code that or anything. We can just select what resistance level applies to a certain object, and that's it. We don't have to worry if that matches this one over here's damage resistance and different things. You would rather just have categories and not have to worry about it. And it's the same thing with status effect. And that's my approach to it, and that's why we'll kind of set those up. And you don't have to do it like that by any means, but that's how I'm going to do it, because I just find it to be better than having to remember. And odds are you're going to mismatch that data somewhere if you don't keep it in one. I preach a lot of single source of truth, and that is kind of like a game-wide fundamental thing that should be one single source of truth, and you not have to worry about it too much. Yeah, and this is me just kind of going over, that we will need in some cases a pretty robust damage calculation. We can't just say, hey, give me the damage that I did. We need to see, hey, the equipment, if you're making something like Valheim or like Borderlands or anything, your equipment is going to have an attack value, right? And so you'll need some way to combine that with the player damage value. And then wait, didn't you just drink a potion that increased your damage by 25%? This is pretty simple functionality that is in a lot of, I say simple, this is pretty popular functionality that in most projects you will need to do some version of that. And I see this covered nowhere ever, and I can't see a case where you wouldn't need to use at least some part of this. And then of course we would also need to take into account any damage resistance that anything will have, which just logically everything will be, like resistant and weak to something, to some things. Like in many cases, you're not going to have something that just any kind of damage, if you're making anything other than just, hey, give me the damage and that. And like I said, the beauty of this system is that we can also just not take into account any of these things. Like when the player takes damage, we don't really care about any of this because, your AI or whatever is not going to have or maybe they will, but presumably they won't need as complex of a calculation. So we can't just build the damage calculation into the system like hard code it. We will need to change it out, and that's a big highlight of the system. And then this is just me going over, like, you have your elemental damage, so you're trying to do fire damage. We're basically going to get a random number between 0 and 1, and if it's greater than our status effect chance, we will. You check the global status effect chance, and I say, you're going to make a call to the status effect manager, and you're going to say, hey, roll a status effect, like roll the dice, and then if the status effect is applied, it's going to do that amount of damage over this duration. And like I said, that's all going to be in a data table. And basically, I just have here that today I wanted to get our damage data figured out. We'll create our custom game mode and game state, and we will. My hope is to at least get this collision. I'm trying to keep this to about an hour, and I've already rambled for a long time, but I'm just trying to explain it the best I can because I feel like that's rare. So forgive me, guys, but I'm just trying to get out how I'm thinking, because I feel like that is the most important thing to any of this, is you have to be able to think about these things in a logical way, and then it's easy to just like look up how you do something in the engine. It's harder to take a big problem and break it down into small problems. I want to build a bench. You have to start thinking like that. Like, well, how do I build a bench? Like, you can't just say, oh, building a bench, it's hard. You have to start thinking, well, how would I build a bench? Okay, first I would have to get some wood, I guess. So I guess I could find a tree. Oh, there's trees here. Okay, and how big do I want the bench? I guess then I'd have to make measurements. And then, the length would be, a quarter of the height, and once you start thinking like that, this kind of stuff becomes way easier. And my number one advice is to practice and try to learn how other people, derive smaller, manageable problems from bigger problems, because you can always find what certain nodes do. The harder part is just like thinking like a computer would, I guess. So yeah, I'm going to try to at least get our universal collision component sorted out today, and if time allows, we'll create some test blueprint equipments and get our anim notify state for collision trace, because that's basically what we're going to use. We're going to use like a window that you can define within any animation. That's what we're going to use at first, but you can also just do it anywhere in the game. Like a projectile is not going to have an animation. You're just going to need to trace for damage while it's in the air or something. You can do that as well, but my hope is to get to this today, if not next episode. All right. And like I said, link for this will be in the description. Also, have a look out for any pinned comments that may be in the description. There was a couple of videos early on where I made some mistakes and I had to put some pinned comments. So I'm going to get rid of this and get rid of that. I'm going to drag my project. This is a fresh third-person character project. I haven't done anything to it. And y'all know me, I like to save a lot. And that's just a habit, guys, just so I don't, if the engine crashes and I'm recording, I don't know exactly what was the last thing it saved. And it, I've had it crash at 50 minutes. I'm 50 minutes into a recording, it crashes and I have no idea what was last saved. And I don't want to, so I just have to start over because I don't know what part was what, and then I don't want it to mismatch, what you're seeing on screen. I don't want there to be a gap in what I've done. I try really hard for that not to happen. That's why most of these are one take. So if you see me saving a lot, that's why, because a crash would mean starting over basically. So, all right, so here we go. So the first thing we're going to need to do, if we look at this, we had damage data. So let's do that. So let's in our content folder, let's say, I'm just going to create a base folder called Universal Damage System. I'm just going to set it to a color so it stands out. There we go. Cool. Universal Damage System. And I would highly recommend doing this in a fresh project. And it's simply because you will presumably need to customize this for many different projects. If you were doing a project right now and it's a first-person shooter, you're going to want to customize that to that first-person shooter to some degree. And if you just do that in that project, you have no means to go back to the base foundation that we're setting up. Because the idea is to set up the base foundation for a damage system and migrate that to any project that may need a damage system. And knowing that you will need to customize it a little bit, but at least you don't have to build it from scratch. And if you do it in the project, if you do these systems in the projects that you're currently working on, you will ultimately ruin them from being reusable. And you will end up making systems that you could have made just once, and then you'll have to remake it every time, and that is wasting hours and hours and hours. And ultimately, that will be the killer of your prototypes, because for you to test an idea out in a perfect world, you would just migrate all the couple systems you need to get to a point to where you can actually test the idea out that you're thinking, right? You can't just test most ideas out from nothing. You have to build up. And most times, if you start from scratch, you'll waste a week just building up to the point to where you can actually test your idea. So the idea with like doing new projects for systems is just that. It's just so ultimately you have this pocket of systems that when you want to test something or prove an idea, you can just get those foundations and they'll do for the time being, for you to just test your ideas or whatever. And it also serves as a solid foundation anytime you may need a similar system. But when you migrate it to other systems, the plan, its intention is to be customized at that point. But if you just did it all in one project, then you just overwrite the foundation you made, and then you never can get it again. And you just have to make it from scratch. And, that may take a week, So yeah, that's my spiel about setting stuff. And I just think that's key that not many people realize or even mention, because I've wasted months and months and months remaking the same stuff. And it really should be a common practice that you make systems in a different project and then migrate it to your main project folder. So if I look in your project, it should just be folders of this system, this system, this system, this system, this system. I think that's a great project management, and I think it sets you up in a good frame of thinking too, because if you're not, you shouldn't make things to just be specific to your project, because your project is going to change in ways you can't predict. So it's way better programming practice to start thinking of these things universally and in isolation, and then maybe thinking about how you would tie it into your project once it's there, All right, sorry guys, here we go. New folder, data. and we're going to say blueprint structure. And so this is what we'll need. This is kind of tricky, but so for instance, when I said we would have an array of damage data, so we need an array of damage data, and if you recall, the damage data are these right here, and we would like to have an array so we can specify different damage types, different damage elements, different damage amounts for those. But we would probably not like to define multiple critical hit chances and critical hit bonuses, right? So on one instance of damage, we would like to say that instance of damage has one critical hit chance and one critical hit bonus, right? It wouldn't really make sense to have multiple critical hit chances and bonuses tied to like one instance of damage or one attempt at damage, right? That wouldn't really make sense. So what we need to do is just have a structure for the damage type, the damage element, and the damage amount, and that is what we can make an array of. So let me demonstrate. And actually, first thing we will need, I'm just going to leave that unnamed for now. I'm going to create our subfolder. So structs, I'm going to drag that in there. New folder for enums. And I usually would do something like this in gameplay tags, like the damage type and damage element. However, gameplay tags are not really good to print. Like if you want to put on the screen, it's just going to be like damage type dot whatever. So I'm doing enumerations simply because it's easier to print. Like with this enumeration, you can get the damage type and just show it on the screen just as it is, and it'll work. Now, even if so I think enumerations fit with something like that is UI based, but otherwise I would be using gameplay tags, and you could still use a gameplay tag in addition to enumeration. I'm just going to use an enumeration though. So I'm going to say damage type. And the parent damage type class, I'm just thinking in my head, right? So we can have our physical damage types, which would be blunt, slash, and pierce. And then we could have our like tool damage types, which will say chop, mine, right? So chop would be trees or axes, and mine would be pickaxes. And then we can say pure. Now, pure is not something that you'll have a damage resistance to or anything. It is just like the tree falling down on you. It is basically unblockable environmental damage. So we have damage type. Now let's get our elements. So, oops, that was the wrong thing. Don't know what that is. Enumeration, let's say damage element. Did I do E? Yeah, E damage element. Okay, let's create a few. We'll put the backslash at first, and we'll say fire, or let's do explosive first. Explosive, fire, shock, explosive, fire, shock, and poison. There we go. And ice, sorry. Or let's say frost. I like frost better, I think. And I think that's all we'll need. So we just have the damage element and damage type. And so the first structure we will need is, let's say, primary damage data. And so our we're going to think of primary damage as just the basic elements of a damage instance, I should say. So we can say damage type, which is our damage type, and then we can say damage element. Or actually, now that I'm thinking about it, yeah, this maybe should be, let's see, S damage type data. Let's do that. S damage type data and just damage type, and then we'll do a float. Damage type and damage amount. And then I'm just going to duplicate that actually and say damage element data. And then in here, I'm just going to change this to damage element. And we can say damage element and damage amount. Cool. So we have one damage type in the amount and one damage element in the amount. Cool. And basically, so now we can go and say structure S base damage data. Or we could say primary damage, or no, let's say base, sorry. Base damage data. And this struct will be the basically like what the main damage data that we'll use. Like everything that we need to organize and stuff will be in here. This will be the final one. And so basically now we can start with, let's see, we know we want the critical. I'm going to stop typing spaces. Critical hit chance. Critical hit. And in the default values, I'm just going to say 0.5 and 0.5. Cool. And so now we need a way to get different versions of that. And we might actually, let's maybe combine them. So we'll say that you need some kind of, no, I guess we don't need to combine them. So let's make one more variable and we'll say damage types. Oh, no space. Yeah, damage types. And we'll say damage type data array. And then we'll say damage elements array. So damage elements, and I'm gonna drag that to the top. And now, there we go. And so now you can imagine in most cases you would just have one of these, but if we go here, you're gonna say, okay, so this is my axe, for instance. Like I'm in my axe, imagine I'm in my axe. You would say, okay, I want my axe to do blunt damage. This is just an example, guys. I want my this axe or this the primary swing of an axe to do blunt damage of 25, and it's an elemental, axe, so 50 explosive, right? And that's fine. Most of the time, you'll probably just do that. But in certain scenarios, you may want to add different types of damages. Like if I'm swinging my pickaxe, right? It may do mine of 25 or 20, let's say. But then you want it, or wait, that was a good example. So let's say this is an arrow or something that does, 20 pierce damage, but then it can also do 5 mine damage. So, when like a pickaxe would have these reversed, you could still mine a thing of stone. It'll just take forever, right? Because it's only 5 damage. So if that makes any sense. And so in most cases you won't have things with multiple elements, but right here you have all the potential to do multiple elements, multiple damage values, and they be tied to basically one critical hit chance and one critical hit bonus. And which we have. So that's pretty much going to be our base data. That's going to be, it's not going to be a lot. Okay, and now let's create our damage resistances. So let's say damage resistance data. Oh, we need that enumeration though. So blueprint, enumeration, E, damage resistance. We will say immune, very resistant. Oops, not resistance. Resistant. We can say neutral. Let's add a description. If nothing is set for this, assume neutral. We'll put that in the description. And then we'll say weak and very weak. Saving, cool. Awesome. And then we can go into our data. Let's create a tables. And we'll get a data table. Well, no, yeah. Yeah, no, we need our damage resist. Sorry. This is in our damage resistance struct. Let's go into our structure and we'll say damage resistance, and we will just assign it a value, damage resistance or let's say resistance percent. And we got to think about this. So when we're resistance to something, yeah. So when we're resistance, if we are very weak to something, it would be, you take 1.5 damage for instance. But if you are very resistant to something, you would just take maybe 0.2 of the incoming damage. So basically, we're going to take our damage amount and we're going to multiply it by this value to get the, we're going to multiply our incoming damage by this level, this resistance level, and we will then add them together, if that makes sense. But let's actually, we need to do the same thing. So let's change the resistance data to damage type resistance data. I'm trying to think, guys. No, we don't need that actually, because let's go back. So let's go back, because I'm thinking this is stuff, we'll say, this is going to be damage resistance. I'm just changing the name a bunch of times. Sorry, guys. Because this is just what we're using to build our table. Sorry, I forgot about that. So going to my tables folder, miscellaneous data table, and we need the resistance data, which will be DT resistance. We'll say definition, resistance definition. And we just need to add all our we'll just need to add all our definitions. So we'll say, if something is immune, it's going to take 0 damage. We'll say if something is very resistance, a quarter sounds about right. Something is resistance, it'll take half. No, 75 probably. And if very resistance, it'll take half. That sounds more right. Neutral will just be 1. Weak will be, it'll take 1 1/4. And let's say very weak will do double. How about that? So double, cool. And then I'm going to see if I can copy this actually and just put that there. Copy display name. So let's just do that. I'm just going to type them in so we can just get the row name. No, it won't let me. Oops. Well, we'll just search by the enumeration in our blueprint function library. So let's just do that. So there we go. And you can use whatever values you want. Obviously, these are just the ones I'm using. So 0, 0.5, 0.75. Yeah, and then 1.25. And then we're doing double damage if they're very weak. So going to our structs, we need... So let's do that. Yeah, we'll create a blueprint structure. And we'll say... We'll say damageable resistance data, because we need to associate, basically, we'll say damage type resistance. And this will be a damage type mapped with a damage resistance. And then we can say damage element resistance, and we'll have the same thing, but it'll be an element. And so now, in any actor, we can say, hey, I want this to be immune to slash damage and, very weak to fire, stuff like that. And you can add multiples of them. Cool. And then let us create one more for, we'll say damage, damage instance context. And we can say damage data. And this will be the, what was it? No, what was it called? Base damage, sorry. S_base damage. No, base, sorry. Where is it? There it goes. Okay, that's our base damage data that we're passing in, and that will be all this that we already kind of did. Now, this is when something is trying to damage, right? So this is like how much damage they're going to do, basically. And so So we have that right now. Now we're going to need some actor values. So actor. So we'll say damage causer. Now this is going to be the actual like actor that has the collision sphere basically. But we can say damage instigator. And I'm thinking let's just put causer right here. Oh, we need one more thing in the base damage actually, and that's going to be our damage calculation. So in our universal damage system, let's create a folder for blueprints. We'll say damage calculation objects. Create a blueprint class of type object. And we will say BP damage calculation. Damage calculation base. Create. And we'll say BP damage calculation complete. There we go. And that's all we need. Because the complete will be the one that we do for the player. And that's kind of, or like when the player is doing damage, I should say. And that's, so in our base damage, we'll just create another variable for damage calculation class. And we'll, damage. I'm hoping that makes sense, but if it doesn't, like with the damage calculation object, I'm not sure if that's going to make sense, but it will if it doesn't. So that should be good. So let's see. So let's go back into our damage instance context. So the causer is going to be like the actor that actually owns the collision trace that we're tracing for. The instigator is maybe the actor that owns that actor. And we are going to say, we're going to create another one for override damage data with tag. Just in case you just, which I will show to do at some point, just in case you want to have everything's damage data in a data table and you just want to pass in the gameplay tag, where that data is housed, you can do that here. So let's actually create use tag for damage data. Let's do a Boolean for that. And that way people can override it that way. And I'm going to create one more value. I'm going to call it payload. And I'm going to instance structure. And we'll use that. Now, you may have problems because I think that is a plugin. Nope. So you may not have this. Wait, that's not it, is it? Yeah, you may not have this enabled. We're probably not even going to use this, but if I do enough research in time, we will. It just won't be for a couple episodes, and it'll be optional. But so you don't even have to add that payload thing. But basically, it's just any information that we need to pass into the damage instance, like the damage trace. We can do that through this. And change it at runtime, change what actual damage we pass in at runtime, which is really, really powerful, but it's an experimental plugin. So we may not even use it, but so you don't if you don't want to do that, you don't have to worry about it. But I am, just to kind of future-proof it, I'm going to, damage instance. Yeah, payload. Okay, cool. There we go. Cool. So we have our damage data, we have our causer, our instigator, use tag for damage data, all that. So there we go. And let's just do one more struct. And this will be damage event, or let's say S damageable event. There we go. And so basically we're going to say gameplay tag. This will be our meta tag, and this will be so we can define stuff like hit reaction or like, fall down or whatever. We can do it in here. And we can say strength, and that is just in case we want to fall down or so. This is a pretty universal value for anything that you're doing here. You can just do it. So like if we have a gameplay tag that is like, launch character in the opposite direction when they get hit, then the strength would be, 1,000, and it'll knock them 1,000 in that direction. In the opposite direction or whatever. And I think that is it. So that's going to be what to happen. And there we go. Now, let's do, in our base damage, let's do one more. Let's do a check receiver. Let's do a check receiver status tags, or let's say check for tags, and let's do that. No question mark. Or let's say required tags, actually. Then we could do restricted tags. That's a smarter way to do it. So if these are empty, nothing will happen. But basically, and I'll demonstrate that right now. If we go to project settings, we go to gameplay tags. Let's make sure you select this default gameplay tags INI. Let's go into name and we'll say status.damage.damageable. So for instance, in status, we'll have effect, burning. Okay, but that's where the status comes from. But the damage is, I need to know this person's status as far as taking damage. And basically, everything will need to be marked as damageable before you can damage it. But also, we can have, like, for instance, if you're rolling or something, you'll be able to say, and this may look familiar because with our gameplay, our gas-inspired blueprint ability system, we use gameplay tags as basically states. And so when we migrate that into here and maybe set stuff up further, we will basically, when something is damageable, we will add this to its gameplay tag manager. Excuse me. And when something is invincible, we'll add this into its gameplay tag manager. And this, where is it? This required tags and restricted tags. Yeah, these are containers. Okay, cool. So the required tags and restricted tags is, if you can think about games with combat, a lot of times there's certain scenarios where if like a boss attacks you, right? Most of its attacks you can probably block, but some are not blockable. So for instance, this required tags and restricted tags, like if something is attacking you, it may not care if you're blocking or whatever, right? So or most of the time it will care if you're blocking, but sometimes it won't. So for instance, most of the time, if something cares if you're blocking, it's going to stay restricted tags blocking. And if you have that restricted tag, it's not going to apply damage, right? But a block, an action or an attack that doesn't care if it's blockable or doesn't care if you're invincible or whatever, will not have any restricted tags. Yeah, if that makes sense. So that's just a way to do like a whole bunch of booleans in one, basically. Because we could have one that we could have a boolean for, hey, should this damage if they're blocking? Hey, should this damage if they're invincible? Hey, should this damage if they're dodging? And all that. But with this required and restricted tags, we can just, do it just like that. And we can just put a required tag for default. We will say they must have, a damageable tag and a restricted tag is invincible. That's 2 checks to make sure nothing gets damaged. That shouldn't be. And we can even, in our default values, we can put the complete calculation. Cool. All right, sweet. So I think that's our bases covered. So let's I'm going to create a folder for components. We're going to create a damageable component. I'm going to duplicate that and say collision trace component. Cool. And while we're here, let's just say status effect manager component. And that should be good. And we go into blueprints. Let's go to game. Let's make a folder called game, and we'll create a new game mode base. We'll say bp_my game mode base. And before we open it up, let's so we can create another blueprint and search for game state. Now, this is the first one you want to do, the game state base, I believe. One of them does not work. So let's try this one. So we'll say bp my game state. So we'll go in here and we can say game state. You see how it says game state base? We can say my game state. And yeah, okay, cool. And then in the default level, they usually will have this override, which we can say none. We can go into our project settings and go to maps and modes. We can say my game mode base. Cool. And now hopefully everything works. No, that doesn't look right. Let's see. Oh, we didn't define a pawn. That's why. So default in our my game mode base default pawn class. Let's just use a third person character. There we go. Cool. So yeah, it's that game state base that you need to create, not the game state that's below it. So in our game state, we will put our collision trace component. Cool. Cool. So let us, we need our blueprint function library too. So let's create a blueprint function library in our blueprints game folder. And we'll say, let's say my damage system function library. There we go. And we'll say if, or no, not if, f underscore get resistance value by level. We'll say e underscore damage resistant. We'll say resistance level. We'll say get data table row names. Oh, not for each loop, sorry. So we'll get all the data table rows. We'll get a for each loop with break, and then we'll just get data table row. And we'll feed it into here, make sure we select our resistance definition. And then we can break off the out row and just double check. We can do equals enum to see if it equals this get resistance level. There we go. And if it does, we will just break this. And then for the return node, we can basically say, oh, we need to save that actually, sorry. So this is the value. So resistance percent local. We can say found resistance. I'm trying to get out of the habit of typing spaces in the variables, guys. Sorry. So we will, if we have found it, we will mark it as true. And this function should be very familiar to you if you followed my other tutorials. We usually always have a function similar to this, or it might be a little different if we're checking by the row names themselves. But I didn't want to bother with typing out the row names and stuff, so I'm just checking by the tag. And we need to mark this as pure. And then off of complete, let's just do this right here. Drag our stuff in. I'm just going to get rid of local. And the resistance percent. So basically this will check an item's resistant level and, you know, basically like transfer it into an actual value we can use. So let's start working on where, oh yeah, that's it. Got your local variables. Okay. Let's create another function in here and say try trace collision. We'll need our collision. No, what was it? It was damage instance. No, damage instance context. We'll say trace instance context. And we'll break it. Oh, we do need one more thing in there. Sorry guys, we forgot one thing. I forgot one thing in that data structures damage. Where was it? Space damage. Yeah, there. Yeah, there we go. No, I'm looking for the context. Sorry guys. Look, damage instance context. Here we go. We can say let's say trace or damage trace shapes. Primitive component, and let's make it an array. So damage trace shapes, an array of them in our damage instance context. So in our function library, we should have this now, which has an input. So when someone calls this function, they will be able to make that data and plug in the trace shapes that it wants to trace. All right, so there we go. Cool. And basically, let's say f get trace shapes map. So we're basically going to need, let's get the primitive component. Let's get an array of them. Trace shapes, which is basically, this is just a helper function I'm making to keep things neat. This is going to be this right here. You can imagine it. Oh yeah, let me just drag that in. You can imagine it just going into that like that. And we'll put the world context for that in the causer. And so, yeah, so basically when someone calls that function, they're going to pass in all the trace shapes, and then that function is going to pass them into here. We're going to do some stuff and then spit something else back up, if that makes sense. So basically we're going to do a for each loop over all of these, and we need to create a local map of them. And that's going to be, oops, spelled it wrong. It's going to be an array, sorry, a map of a primitive component and a vector value. So we'll say component location map local. Cool. And we will add that. When we loop over them, we're going to get the component, we're going to plug it into there, and we just want its location. There we go. Because we want this location because basically a lot of things move too fast for the system to trace reliably, or not, I shouldn't say reliably, because it can reliably trace it. It's just, it's not set up to do so. It's not set up to trace things moving really fast. And what'll happen you'll have huge gaps in your traces, like most of the time. And so to get around that, we are basically going to trace when we're tracing something, we're going to trace every frame from its previous known location to its current known location. And if that's probably not going to make any sense, but we are basically building its previous frame's location. So basically we're going to come in here, we're going to get the components, and we're just saving their location, right? So, and when we spit that back out, when we save their location and it goes to the next thing, it's now the next frame, right? So now we have their previous location. So when we do our trace, we just get their world location as the end value and this as the start value, and now we have a very, 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 very reliable trace that will trace every frame from its previous position to its current one, if that makes sense. So that's all we're going to do in this function, is basically build this map and then return it. So we can get our map and do that. There we go. So if we go into our, so now we have our map. We need a local variable in here for already hit actors local. There we go. Just while I'm thinking about it. And so let's see. Let's make another helper function for, so we'll put this as collision trace function. And we will just get a box trace by, we'll get a multi-box trace by channel. There we go. And we will drag the start location, the end location, the rotation, and we can actually, let's create a variable for a single component. So we'll say trace component. We'll do that. And then we have the half size, which right here, I think we're going to have to cast this to a box volume. Cast to box component. I think that's it, but we can convert it to a pure cast because we need its get box extent. And let's try this without doing this, because we can do it another way. I've just found it to be less reliable, but we can just say get component bounds and get the box extent and divide it by 2. But I found a lot of times this doesn't work, but let's try it. Or let's not divide it, actually. Let's multiply it by 0.5. And that might work, because I believe the half size is half of the box extent, which is the, the size. I'm just going to plug that into the world context. Oh, we need our custom trace channel. Just go to the collision, new trace channel. We'll set to ignore. Call it damageable. Back in our function library, we should, nope, compile maybe. Yeah, damageable. We'll need another helper function. And all these helper functions, guys, don't forget, it's if you're wondering like why or what are all these functions, I know it gets a little more confusing when you create all these helper functions, but they are more or less to separate your ideas and for organization purposes. Like I can do all this stuff I'm making functions for, I can basically just do it all in here, but you wouldn't be able to read it, you wouldn't be able to follow it, and it would just be a huge mess. So all these helper functions are just to make things organized. Like this function is basically just going to trace and then return if it hit anything. So, you know, so it's like I try to do that just because then at a glance, if I'm looking at the function list, I can kind of get an idea of what I was even doing, what I was thinking, all that stuff. So let's say get actors to ignore. And we can damage instance context. So we'll say damage instance context. And that will basically give us the one that's doing the owner. So the one that's actually trying to do the damage instance and the owner, if it has an owner, you know. So basically, and you know what we can do, guys, is we can actually go back into our damage instance context, and let's just add a variable for that. So actor array, let's say actors to ignore. There we go. I'm just going to put that above the trace shapes. I'm actually going to put the trace shapes first and the actors to ignore after that. I'm going to put the damage data after all the actors. Yeah, that's cool. That works. So if we go back into we don't even need this function now. If we go back into here, we can just, okay, wait, actually, let's disconnect this trace component and pass in the whole context. So damage instance context, we'll say, oh no, not the no, hold on. I'm going to undo that. Sorry, guys. So we're at just the trace component again. And let's just pass in the actors to ignore. So an array of actors. Oops, not vectors. Actors. Ooh, not actors. Actor. Oh my gosh. Actor. Array of actors. Actors to ignore. Boom. Cool. And we can actually do this too. Let's create an input for draw debug. Boom. We can do a select off our draw debug and then just get draw debug, which you'll be familiar with this process by now if you follow my other tutorials. So if it's true, we can just drag this true into here for debug settings. And if it's not, we'll do nothing. Cool. There we go. So we are basically tracing. We're going to have a box shape that gets passed into this, and we're basically just doing a trace for it. And this will give us all the results. Cool. Now, first thing, yeah, that is in there. Okay, so let's see. This is not, I'm going to actually control X that in our try trace collision. I'm going to control X that actors to ignore. And where is it? Collision trace function. Yeah, I'm going to just try to click right there and paste it. Yay. Okay. It brought that local actor over to this one because this is the one we needed in. And let's actually, no, that's fine. Yeah, cool. So, and we're doing a multi-trace because, no, I'm thinking actually, no, yeah, let's do multi-trace. A multi-trace is just going to return multiple actors that are hit with the same trace, which we want to happen. We could do a simpler version with just a single trace and then, you know, fix it after, but I think this will work. So we have this, we're tracing by that channel, right? And so we will check if the thing we hit is actually blocking, you know, the damageable channel. And if it is, we will get all the things that it hit. And the first thing we want to check is if it's the actor it hit is in, wait, what is it? Oh, that's primitive components. We need actors. Change that variable, please. If you right click, we can refresh it and put it in there. Yeah. So the first thing we want to hit is we want to make sure that the hit actor is not in this array, which before I forget, I'm going to get that local array and clear it. So every time we trace, it's just, you know, it's getting rid of what was in it, basically. So when we trace, we're going to see, hey, is this actor we hit, is it in this array? And if it's not, then we can proceed. If it is, then we will, which I'm going to make another placeholder for that. So spawn effects. So we will say vector location. So later we will spawn like what generic impact effects we can use. And we might actually want to, let's say actor, we might want to attach it to something depending on how you do things. So we'll say, we'll do this right here, primitive component for hit component, and then we'll have an actor input for hit actor and a location. So right here. So if it is, and that's not even going to go there actually. So let's make a return node in this collision trace function and just do a success. Well, I'm thinking about like just do a success boolean. And if the hit actor is not in this array, that means it's already in the array. That means it's already been hit. So in which case we will exit false right here and then just uncheck success, right? So, but if it isn't, then we can say, okay, this is a damageable item that we have not hit yet. So let's move forward. But the first thing we're going to do is add it to that array. So imagine this, it's tracing over a period of time. It traces once, it hits the actor. It says, oh, it's not in here because the array is empty. Okay, well then we can proceed, but add it to that array. Now the second trace, it hits, or like as the trace is still going, the tail end of it hits the same actor. It goes in here and checks and it returns false because we've already hit the actor and moved forward with the process, if that makes sense. Okay, and on that, and after that, we're going to get the hit actor right here. So basically, this is like, okay, we have our hit actor and we're moving forward, but we still don't know if it is this could be a surface that is not actually damageable. We just want to, do sound effects or visual effects when we hit it, but we don't want to actually subtract any damage from it or do any other logic. We don't know which one it is, if it's a fully damageable one or just like a surface that we want sparks to fly off of. So off the hit actor, we can then check if the damageable component that will be on literally every actor that is damageable, we can see if that is on that hit actor. So we can just say is valid. And if it is not, then that is when we will just spawn a VFX. We could say hit actor, hit component, and I'm going to give the world context to the hit actor. I'm just tightening this up, and the location will be, and actually guys, all right, hold on, because we need to just make this the hit result, because in a lot of cases we're going to need the normal and all that. I was trying to avoid it, but let's just make this a hit result. Hit result, hit result. We'll connect that. Remember, that's the hit actor that we're connecting that to, and then the hit result is just going to be this right here. Boom. Tidy this up a little. So, and remember, this is if the damageable component is not active. So that means that it is not a damageable, it is just a surface. Let's go into our damageable component real quick. Let's create a custom event for try apply damage. Or sorry, try apply, oh my gosh, try apply damage. And the only thing we need really is the, that's my timer, guys, sorry. I'm gonna try to wrap this up real quick. So that's our damage instance. This is our damage instance context. So let's say damage instance context. And this is really the only thing we need, because from here we can do all our calculations and stuff like that, because every damageable component next episode we'll be creating our damage resistances and stuff. So this is where we're going to spawn the calculation object. We're going to check our damage resistance and all that. So this should be, let's comment it real quick, try apply damage. We can go back into our function library. So that is if it's not valid, but if it is valid, we have the damage component right here. We need to apply damage. Try apply damage. And if we try, we can actually get this right here. And in both of these scenarios, well, we should maybe separate them. So let's say successful hit. Or actually, guys, we should probably do this. Create enumeration. Call it or let's say trace hit type. We'll say damageable, non-damageable. That makes sense. Then we can go into our return node, and let's just take that. Well, let's say none first. Let's add an option to this and just put none as an option, and then damageable, and then not. Well, let's do not damageable and then damageable. Just making sure. Yeah, cool. And so in our function library, we can just get rid of that, and then, oh no, wait, that was the wrong thing. Sorry. No, that's right. Yeah. So we get our, what was it? Trace hit type. There we go. So on the damageable component in the is valid, on false, we know it's a non-damageable. Copy that. And right here, where we're trying to apply damage, it's a damageable. And I'm going to duplicate it one more time. Go here. And this is, oh, we can even do that. Let's go back to that and add another one. So we have an option for none. We have an option for already hit actor. We have an option for non-damageable and damageable. Cool. Just for clarity's sake. So right here, we can put already hit actor. And here we can put, what was it? Yeah, this would be none. Sorry, brain fart. Cool. Yeah, so as complicated as this may seem, it's rather straightforward. We will need to get, oh yeah, we will need the context. I'm silly. Sorry guys, as an input on this function, we will need the context. So damage instance context. We can drag that up. Yeah, and we can actually get rid of that actors to ignore. So we got trace component, trace context. We can break this and just get actors to ignore. Where is it? There it is. Actors to ignore. And what do we call that? Trace context. Let's go over here. Say get trace context. And we'll need that to pass over there to our damageable component. Cool. And so in our game state, okay, we already have our collision trace component. And basically, we're just going to implement that function to next video. We're going to basically implement this function in our game state as we go. So when something calls, it's going to call into here. It's going to run that function, handle everything, and then communicate with the damageable. You know, it's not really going to do, we're not really going to do anything in the game state. We're going to do a couple things in this collision trace component, but we'll set all that up next time. The main functionality of this is the data. And then this right here, this is kind of our main thing, you know, our main. In the collision trace component, we'll have all kind of different ways to do the trace. Like maybe you want to do it over time. You want to do it like just once, all that stuff. But it's basically just that function, try trace collision that, oh yeah, so we need to do that. Sorry. Oh, wow. Okay, yeah. Cool. So, that's right. So basically, I totally forgot that it was inside of one. So basically, remember, we get our component location map, and we're just going to loop over that, right? Because that is going to define how many, that's going to have our array that we pass in of damage trace shapes. And so we have the components and we get the world location, right? And so that's going to be the end. No, sorry, that's going to be the start. The end is going to be its current location. I'm sorry, this is its current location. That is going to be its end. Its previous location is going to be what we get from here. And there's no scenario where this should produce a component that is not in the map, but just to say. And if we go into this, we should probably clear this from the start. This get trace shapes map. Let's clear that and drag it in. And then where was it? Yeah, try trace collision. So we have all that going, right? And then we just drag in the component we're tracing. We can even look, get world rotation. Put that in there. And we have our draw debug and stuff. So let's just do that right here. Draw debug. Draw debug settings. And our world context, we can just give to the component. Boom. Trace context, I think we have. Yeah, get trace instant context. Boom. Beautiful. And then we have a return node for a successful hit. Boom. Relatively simple functionality that is going to carry us a long way, honestly. So yeah, I hope that makes sense, guys. That'll conclude this episode. If you have any questions, be sure to catch me in the Discord or comment on this video, and I'll try to help you out. Also, just in case I've made any mistakes or anything like that, I mean, we haven't even tested anything, but just in case, be on the lookout for a pinned comment. And there's nothing really for us to test at this point. I just don't want this episode to get super long, so I'm going to end it here. And next time we'll get our damageable and collision trace component going with animation notifies and a test equipment or something, and we'll find out a way to start testing this out. But to set the data up and the few functions in the function library that we need, it kind of took this first episode. So with that, I'll catch you guys later. Thanks a lot.